A requirement describes what must be true, and a control describes how an organization makes it true. The requirement is the destination, while the control is the road that gets you there. For example, the requirement might state that access to sensitive data must be limited to authorized users, and the control could be role-based access with periodic reviews. Confusing the two leads to weak designs because teams debate technology choices before agreeing on the outcome they must achieve. Keeping the distinction crisp allows flexible implementation while preserving accountability for results. It also lets auditors test outcomes without prescribing a single method. The requirement sets the bar, the control is the method of clearing it. A test procedure is a defined set of steps used to examine whether a control works, and objective evidence is what the procedure collects. Evidence is observable and verifiable, like a dated log entry, a configuration export, or a sample of approved requests. In practice, a good test procedure names who performs the step, where the data resides, and how success is recognized. A weak test says to check the setting. A strong test names the system, the screen, the field, and the expected value. The goal is repeatability so that different reviewers would reach the same conclusion. When procedures and evidence pair well, assurance becomes predictable rather than subjective. Scope defines what systems, data, and locations are in play, while factors and tailoring determine how requirements scale to that scope. Not every environment has the same risk, so not every control needs the same depth. Tailoring means right sizing without watering down the intent. For instance, a small application with no external access may justify simpler monitoring than a public portal that handles sensitive records. Factors might include data classification, transaction volume, or connectivity patterns. By stating scope, naming factors, and documenting tailoring choices, a team shows thoughtful control design rather than one-size-fits-none. Clear scope decisions prevent surprise work later and make assessments more efficient. Inheritance and the shared responsibility model describe how one party relies on another for specific controls. If a platform provides hardened infrastructure and managed backups, the customer can inherit those capabilities rather than rebuild them. However, inheritance is not abdication. Someone still verifies that the promised control exists and applies to the in-scope assets. Shared responsibility clarifies who handles configuration, monitoring, and incident response across layers such as network, platform, and application. A practical approach documents which controls are provided, which are configured by the tenant, and which are entirely customer managed. This clarity stops gaps from forming between providers and users. Sampling, populations, and timing windows make testing manageable and fair. The population is the full set of items under review, such as all user access approvals during a quarter. Sampling selects a subset that is large enough to be meaningful and small enough to be practical. A timing window defines the period of interest so evidence is current and relevant. Random samples reduce bias, while risk-based samples focus on areas with higher impact. A well-defined approach writes down what will be sampled, how many items, and how the window supports the objective. By handling these mechanics openly, teams avoid debates about cherry-picking or outdated proof. Prisma maturity levels provide a common lens for judging how well a control is established and sustained. The sequence often moves from policy and procedure through implementation, then into measured and managed states where performance is tracked and improved. The power of this lens is that it recognizes progress without pretending that partial steps equal full maturity. A team might implement a control but not yet measure outcomes. That is honest and useful. Scoring then guides investment by showing where measurement and management will yield the biggest risk reduction. Over time, maturity should rise not by slogans but by evidence of consistent practice and feedback loops. Narrative, mapping, and cross-references tie the work together so reviewers can follow the thread. A narrative explains how the control operates in this environment, using plain language that a new teammate could understand. Mapping shows where the control satisfies specific requirements across frameworks so one effort serves many masters. Cross-references point to related procedures, system diagrams, or tickets so a reader can jump to the source quickly. A strong package reads like a story with signposts rather than a pile of disconnected artifacts. When the pieces link cleanly, the assessment feels natural and the organization preserves its knowledge for future cycles. Quality assurance expectations and gates provide confidence that work meets the bar before it moves forward. A gate might require peer review of narratives, verification of mappings, and a second look at samples and counts. Quality steps do not add bureaucracy when designed well. They catch ambiguity while changes are cheap. Think of a checklist that confirms dates, names, and system identifiers match across artifacts, and that screenshots are readable and attributable. Each gate exists to protect clarity and consistency. Over time, these practices raise the baseline so fewer issues appear late in the process, when corrections are harder and trust is more fragile. The certification letter, the report, and the RDS are the main outputs people will handle and share. The letter is the short proof that stakeholders ask for first, while the report explains results with the detail needed for governance and remediation. The RDS serves as the structured set of requirements and data points used to manage scope and track responses across controls. Together, these artifacts become the organization's reusable evidence kit. When kept current, they shorten vendor reviews, inform leadership decisions, and guide the next cycle of testing. Treating outputs as living references turns assessment effort into durable value. Operating rhythm and evidence hygiene keep the program steady between assessments. An operating rhythm means regular cadences for reviews, approvals, control checks, and artifact refreshes so work does not pile up at the deadline. Evidence hygiene means naming files consistently, capturing screens with context, and storing items where others can find them. A practical rhythm might include monthly access reconciliations, quarterly risk reviews, and routine validation of inherited controls. Small habits matter, like recording timestamps and system paths on every capture. When hygiene is strong, assessments feel like confirmation rather than a scramble. The day-to-day discipline is what makes quality repeatable. This episode offered a forward mental model. Words shape actions, actions produce evidence, and evidence earns trust. By keeping distinctions clear, defining scope with intent, and using shared responsibility wisely, teams create controls that stand up to testing. By sampling fairly, scoring maturity honestly, and telling a coherent story, they make reviews efficient. By turning findings into corrective plans and passing quality gates, they improve without drama. And by maintaining a steady rhythm with clean evidence, they make success boring in the best way. Carry this model into your work so every term points to a practice, and every practice leaves a reliable trace.